Good afternoon, everybody. Muy buenas tardes. I hope everybody is doing well. I'm doing this video on two problems from your assignments that are going to be due next week, just to give you a little introduction to what you're going to be doing. So on the whiteboard here, it's filled with a lot of information, so follow my finger here. So this is your worksheet, and this is number 15. So you have two items that you have to turn in. One is the worksheet, and you're only doing 15 to 26 on this worksheet. Worksheet's on Google Classroom. And then you have problems due on page 561. So this is number 15, like I said. Follow the black in here. This is what's given, and you have to find the cosine of theta over 2. So what I did, this information right here, I translated it to this right here. And through the Pythagorean theorem, figured out the length of this is 24. So to find a half angle of cosine, you have to have the value of cosine of theta. So from your drawing here, you can see the cosine of theta is 24 over 25. Then I use the formula, the half angle formula, of course, cosine from page 556. So I'm going to leave plus minus all the way until the end, and I'll tell you whether I'm going to choose, why I'm going to choose positive or negative. So right here is the formula for where cosine theta is in the formula. I replace it with 24 over 25. Then I'm just simplifying, coming up with a common denominator and adding the numerators. So get this. Simplifying a complex fraction by multiplying by the reciprocal of the denominator. So I have 50 right here. Then simplifying the numerator and denominator, rationalizing the denominator. So then I end up with positive or negative 7 rad 2 over 10. And my final answer, the final answer for this, I'm choosing negative 7 rad 2 over 10 as the final answer. This is the correct answer. So let's talk about why I decided to reject the positive and accept the negative. So my answer is in green, so I want you to go to green up here. So originally you're told that theta is in the fourth quadrant. It's in between 270 and 360. But you're looking for half of that angle. So if you go up here, so the original restriction on the angle I put here, and I cut everything in half. And when I do that, half of the angle is known to be between 135 and 180. Well, 135 and 180, which quadrant does the half angle fall in? So it wouldn't be the fourth, it would be the second. And cosine is negative in the second quadrant. So that's why for your final answer, you choose the negative sign instead of the positive. So to reiterate, it's not based upon the original drawing of theta, it's based upon half of theta. So that's why we end up in the second quadrant and accept the negative. So that is one problem from your worksheet. Now, you also have book work to do. So what I'm doing here is I'm showing 561, number 45. This is the original problem here, sine of 1/2 inverse cosine of x. So you want to read the instructions. The instructions say that they want the answer in terms of x. So watch up here. So I converted this here, so the inverse cosine of x. Remember, you're looking for the angle whose cosine is x. So this means you're looking for the angle. Remember that this is also converted to this. It also means the cosine of theta is equal to x. These two mean the same thing. Okay. So knowing here that this represents the angle theta, I just replace this with theta right here. So this means I'm looking for the half, I'm going to use the formula for the half angle of sine. So this is what I have right here. That's the half angle formula. And from here, remember the answer has to be in terms of x. So I know that cosine of theta is equal to x, so I replace that with x. This is the answer here. Now, since I'm given theta and the x is positive, then I'm going to assume that I'm in the first quadrant, so that I'm going to reject the negative and accept the positive. So you can leave it with the positive sign, or you don't have to put the positive sign because that's under, if you don't have a sign, it's understood to be positive. So this is your answer right here. Right, so two different problems dealing with half-angle formulas. Right, so remember, if you have any questions, just email me. I'll be more than happy to either do a slideshow or a video. Slideshows are a little bit faster or quicker for me to do because I don't have to upload them. Okay, so take care, everybody, be safe, and I will talk to you soon.